Now we are starting question number 2. Of this mechanics paper. A particle of mass 0.5 kg starts from rest and slides down the line of the greatest slope of a smooth plane. The plane is inclined at an angle of 30 degrees to the horizontal. Find the time taken for the particle to reach the speed of 2.5 meters per second. And the B part, when the particle has traveled 3 meters down the slope from the starting point, it reaches a rough horizontal ground at the bottom of the slope. The frictional force acting on the particle is 1 Newton. Find the distance of that particle travels along the straight ground before it comes to rest. Since in question number 2, the particle is going to be moved on the inclined plane down the slope, starting from rest. So, this is A, this is B. Now at A it is 0, at B the speed is 2.5 meters per second, and this is inclined at an angle of 30 degrees to the horizontal. For the first part, you have to take the time. So we know at this point, particle is there. So we can resolve it into the components. We know that this is normal reaction R, this is mg cos of theta, and this one is mg sine of theta. Because it is coming downward, so frictional force is upward there. But since frictional force is equal to 0, as it is mentioned in the question statement, because it is smooth surface there. So we know from this equation, driving force minus resistive force is equal to net force MA. For this driving force, this mg sine theta is responsible for coming it downward, minus frictional force, that is equal to MA. But frictional force is equal to 0. So mg sine theta is equal to MA. M and M cancel out. G value is 10. Angle there is 30 is equal to acceleration A. So acceleration A is equal to sine 30 is half. So that thing is equal to 5 meter per second square. Now we are going to find out this time it has to take to reach a speed of 2.5 meters per second. We know from this equation V is equal to U plus AT, where V is 2.5, U is 0 there, acceleration is 5 into time t there. So time t is equal to 2.5 over 5, or that thing is equal to 0.5 seconds. So this is the first answer, that it is going to take 0.5 seconds to reach the ground. Second part, this particle, after covering a distance of 3 meters, it moves on the horizontal surface, where we know that this R is balanced by the weight, but the frictional force acting on that plane on this horizontal surface is equal to 1 Newton. So first of all, we have to calculate the speed at this point C when it moved towards the D point, but it is going to be at rest. So at D point, the final velocity is equal to 0. And now we have to calculate the speed at C there, which is equal to U. So first we have to find out the value of U there, which is being calculated in this way, that it has moved a distance of 3 meters along that surface. So we are going to calculate the speed according to this object there. But when it is coming downward, it has driving force is mg sine theta. So mg sine theta is your driving force for that part. Since it is moving downward when it has covered a distance of 3 meters, we already know the calculation of this acceleration, that is 5 meters per second square. So we can use this equation of motion v square minus u square is equal to 2as, where v is going to be calculated there, u is 0 square, 2 we know, acceleration is 5, and the distance it has traveled is 3. So v square is equal to 30, or v is equal to 30 square root meter per second. So at this u there is square root of 30 meter per second. Now from C to D, we have to find out the acceleration of that particle there. Since there is no driving force, minus resistive force is equal to ma. Driving force is 0, frictional force is 1, mass is there 0.5 into acceleration A there. So acceleration A will be equal to 1 over 0.5. So that thing is equal to minus 2 meter per second square, which is deceleration from this C to D point. Now we can have to find out the total distance traveled from C to D. We know again we will use this equation v square minus u square is equal to 2s. V square is 0 minus u square is basically this 30 is equal to 2. Acceleration we have calculated it there, that is equal to minus 2 into s, the distance from C to D there. So minus 30 is equal to minus 4s, or s is equal to 30 over 4, or that is equal to 7.5 meter, which is the distance traveled from C to D there. So these are the two parts for this question number 2 of this exercise. Now we are starting question number 3 of this paper for M1 of 909. A lorry of mass 24,000 kg is traveling up a hill which is inclined at 3 degrees to the horizontal. The power developed by the lorry's engine is constant, and there is a constant resistance force to that motion of 3200 Newton. When the speed of the lorry is 25 meters per second, its acceleration is 0.2 meters per second square. Find the power developed by the lorry's engine. This is part 1. Now part 2. Find the steady speed of which the lorry moves up the hill if its power is 500 kilowatts and the resistance to the motion is remaining 3200 Newton. Since it is moving upward and the power is basically equal to driving force into velocity, we don't know the driving force, but we know the velocity is 25 meters per second. So we have to calculate the driving force there. So first, because it is moving upward, so you will resolve it into components. This is R, this is mg cos theta, and this one is mg sin theta. And there is a resistive force which is downward. with a magnitude of 3200 Newton. And this one is the driving force there. So from this we know that driving force minus resistive force is equal to net force MA. Driving force we don't know, but the resistive force is 3200 Newton plus mg sine theta, because this force is also acting against the direction of that motion there. Mass of that particle is 2400 kg into the acceleration of that particle is equal to zero point 0.2. So driving force will be equivalent to 3200 plus m, that is 2400, sorry, 1000 into g, that is 10, into sine of that angle, that is 3, plus 24,000 into zero point 0.2. So the driving force will become equivalent to so the driving force will be equal to 20561 Newton. So power is equal to driving force into velocity. So that thing is equal to 20561 into 25. So that thing is equal to five one four 025 watts, or you can write this thing as 514 kilowatt according to this rounding off to this value there. So this is the first part, that you are going to find out the driving force of that engine, and then you have to find out the power, which is going to be calculated equal to 514 kilowatts. And then the second part, we are going to find out the second part, the speed of that when the power is going to be increased to 5500 kilowatts. So now power is equal to 500 kilowatt, that will be equal to 5000 watts. But power is basically equal to driving force into velocity. So velocity is equal to power over driving force. So we are going to find out that velocity there. But first we will calculate the driving force to that particle. So because it is moving at a constant speed, so that means acceleration is equal to 0. So if we use the same equation there, driving force minus resistive force is equal to ma. So that thing is equal to 0. So driving force is equal to the resistive force, and that thing is equal to 3200 plus 24,000 into G is 10 into sine of 3. And that driving force will be equivalent to 15761 Newton. So velocity will be equal to power divided by 15761 and that value is equivalent to 31.72, and that is meter per second is the steady speed due to which it will move upward when it is moving with a constant speed there. So this is the solution of question number 3 for the second part.